All right, guys, so today we're going to continue on with chapter 5 and talking about segments and lines in triangles. So the next one that we're going to learn is called the median of a triangle. And a median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. This does not mean it's a bisector of an angle or a side. It simply goes from the vertex of one side across to the midpoint of the other side. And the reason I know that D is the midpoint is, again, because of these two congruent symbols right here. That means that D is in the middle of that entire segment AB. All right? So that is going to be medians. Now I could draw more, and you don't have to do this, but I could draw more. Simply go from the vertex and draw it to the opposite side, creating two equal parts over here. Vertex, that was not good. Vertex, opposite side over here, creating two equal parts. Now, that point where those three medians intersect is called the centroid, okay? Your centroid is where three medians intersect, and it is always located inside the triangle. You will never have a median outside or on the triangle, okay? So centroids are always going to be located inside the triangle. All right, this next piece is going to be the piece that you really need to know with centroids. Your relationship of a centroid is as follows. This big piece of your centroid, so the longer piece, is going to be 2/3 of the entire thing, okay? So that long piece is 2/3 of this entire median AY, all right? Or the next part that I'm going to tell you, you definitely need to write down. If you notice, there's a long piece and a short piece. Let me make this skinnier. Okay, your long piece is going to be in yellow. Your short piece I have here in green. Okay, so your long piece, so long, is equal to 2 times the short piece. So your yellow piece is double the length of your short piece, or half of your long piece is equal to the short piece. Okay, so again, if you look at each median and break it down into short and long, that is your other relationship. So let's say we know that AP is 10. Well, I know that half of the long piece is equal to the short piece. That means the short piece is 5. And then vice versa, if I do it this way, if I know that this short piece, let's say, is 7, then I know my long piece, the yellow piece, is double that size. So that means the yellow piece would be 14. Okay, so that's going to be the relationship that you deal with a lot more. This whole 2/3 thing, you won't really see me work with it very often, just because it is a little more confusing for everybody. All right, so if you just break it down into short and long, that makes it easier. And then if they ask for the whole thing, all you have to do is add those two pieces together. All right, so keep that in mind when we're working on this next part. And just a fun fact, the centroid is known as the center of gravity of a triangle because it's the balancing point. So let's say you had a triangle, you had a 3D triangle and you wanted to balance it. If you found the centroid of that triangle, it would balance right there at that point. All right, so let's look at example 1. Example 1 says that SP is 16. So I know that this length is 16. So if I look at the whole centroid, or whole median here, I can see that this is the long piece and that this is the short piece. And again, the reason I know that these are medians is because, look, they come from the vertex and go to the midpoint of the opposite side. Same with this one. Vertex, midpoint of opposite side. Vertex, midpoint of opposite side. Okay? So that is how I know that these are medians. So if I want to find the whole length of SM, all I need to do is figure out this green part, PM, and then add them together. So if we look back up here, your short segment is equal to half of the long segment. So if my long segment is 16, well, half of 16 is 8, so that means PM is 8. So to find SM, you just add those together. 16 plus 8 is going to give you 24. Okay, so SM is equal to 24. All right, so again, I will do that every time because to me, it's much easier to cut something in half or double it than find 2/3 of it. All right, now they tell me that LP is 9. And they want me to find LT, the whole thing. Well, if I look at the whole median here, LT, I can see that this is my long piece and this is my short piece, okay? So I'm given my short piece in this situation, and I know that the short times 2 is equal to the long. So if I double my short piece, I will get that long yellow piece, PT. So 9 doubled is 18. Let me see if I can make that skinnier. Okay, so to find the whole thing, LT, I just add those together. So LT is going to be equal to 9 plus 18, which is going to give me 27. So LT is equal to 27. All right. And finally, they tell me that this whole length RN is equal to 33. Okay, so I know that this whole length is 33. So I have my long piece and I have my short piece. Oh, those colors are backward. I have my long piece and I have my short piece. Okay, so I want to find this length, this green length, PN. All right, so this is the only time you're going to see me use thirds. If I know the whole thing is 33, and I know that this yellow segment is 2/3 of the whole thing, well, then all that's left is that this is 1/3 of the whole thing, okay? So the yellow piece is 2/3 of the whole thing. The green piece is 1/3 of the whole thing. So if we want to find the green piece, we have to find 1/3 of 33, which is also 33 divided by 3, which is going to give you 11. So you can say that PN is equal to 11. All right. So usually you're going to see me use the 1/3 more often, or you can see the 2/3. But again, using the half and the double is going to come up way more often, but keep the 1/3 and 2/3 in the back of your mind. All right. So again, your long piece is 2/3 of the whole thing, which means your short piece would have to be 1/3 of the whole thing. Okay, so that is medians. Now for this next one, you're going to see us graph medians. So the diagram shows the plane for a triangular piece of mobile. Where should the sculptor attach the support so that the triangle is balanced? Well, remember that when you balance a triangle, it is the centroid. So we want to find the centroid of my triangle. So in order to find my centroid, we have to find the medians. And to find our medians, you're going to first find the midpoint of each side, and then connect that midpoint to the opposite side, or excuse me, the opposite vertex. And I'll show you what I mean by that. Okay, so first let's find the first median. So we're going to find the midpoint of RP first. So remember, your midpoint is x2 plus x1. Why is that so fat? x1, there we go, plus x2 over 2, comma, y1 plus y2 over 2. Okay, so that's our midpoint. So if we go ahead and do the midpoint of RP, let's make this one x1, y1, and this one x2, y2. So that is 6 plus 3 over 2, comma, 4 plus 0 over 2. 6 plus 3 is 9. 9 divided by 2 is going to give you 4.5. 4 plus 0 is 4. Divided by 2 gives you 2. So locate 4.5, 2 on this segment PR. So when I go to 4.5 and up 2, I end up right here. Now, when I say I want to connect that to the opposite vertex, the opposite vertex is over here, okay? So we want to connect that to the opposite vertex, and I'm going to do my best and sketch. There is one median, all right? So let's find the next median. So I'm going to find the midpoint of QR. So let's make this x2, y2. So we have x1, y1, x2, y2. So that's 6 plus 0 over 2. And 4 plus 8 over 2. So 6 plus 0 is 6, divided by 2 is 3. 4 plus 8 is 12, divided by 2 is 6. So we go ahead and locate 3, 6. 3, 6, which is up here. And we connect it to the opposite vertex. So your opposite vertex is down here. And that's going to be a straight line down. And then finally, we need to find the midpoint of QP. I'll change this one to x1, y1. So that is x1 plus x2 is 3 plus 0 over 2, comma, y1 plus y2 is 0 plus 8 over 2. So 3 plus 0 is 3. Divided by 2 gives you 1.5. And 0 plus 8 is 8. Divided by 2 is 4. So 1.54 is up here. Connect it to your opposite vertex. And it goes right through there. And if you notice, you get one single point where these intersect. So your centroid is at the point +3, +4. And there's your answer. So that's all you do to graph your medians. Find the midpoint of each side and connect it to the opposite vertex, the vertex that is across from that midpoint. Okay? So, moving on, we are going to learn about midsegments now. Okay, so that was medians and centroids. Now we're going to talk about midsegments. Midsegments are pretty easy. A midsegment is just the segment that connects the midpoints of two sides of your triangle. So DE here is a midsegment because it connects D and E, which are our midpoints. And again, I know they are midpoints because of these congruent symbols here. Okay? So if we are connecting midpoints of each side, well, there'd be a midpoint here. Let's name it F. There's a midpoint here and a midpoint here. So if I connect all of those, we'd have DF is one and FE is another. So you can draw 3 total midsegments in your triangle. Okay? So you're going to see those a lot. You're going to see all 3 a lot. Okay, this next part's important. Your midsegment theorem says that your midsegment is half the length of your opposite side, okay? So DE is going to be half the length of AC. The other thing you need to know is that the midsegment is parallel to its opposite side. So DE and AC are parallel to each other. Up here, DF and CB are parallel to each other. EF and CA are parallel to each other, okay? So you're going to have 3 parallel segments in each figure if they draw all the midsegments. And you need to know that your midsegment is half the length of the parallel side, or the side that it is opposite of. Okay, so we're going to get an example of that in just a minute, but just remember, it is half of the opposite side. All right, so let's look at our example here. Oops. We want to find the 3 pair of parallel segments in triangle DEF. Okay, well, in order to find your 3 parallel segments, you have to find each midsegment. So OM is 1, and OM is going to be parallel to its opposite side, which is EF. So we can say that OM is parallel to EF. Our next one is going to be DE is going to be parallel to its opposite side, MN. So MN is parallel to DE. And finally, we have this last midsegment, ON, and that is parallel to its opposite side, DF. So we have ON is parallel to DF. Okay, so if you see how I did that, they look parallel and they are parallel. Okay, so the sides that look parallel are going to be parallel to each other. The little one is the midsegment, and it is half the length of the side that it is parallel to. Okay, so now that we have our relationship set up, we can go ahead and find some side lengths. So we have that DE is 42, OM is 13, and DM is 11. Now notice all these congruent symbols. Keep those in mind when we're doing this problem. Okay, so we want to find the lengths of MN, EF, and OP. So let's find MN first. So MN is going to be the midsegment that is parallel to DE. And we know that MN is half the length of DE. So MN is equal to 1/2 the length of DE. So when we plug that in, we have that MN is equal to 1/2 DE, which is 42. And so when you cut that in half, you get that MN is 21. Okay, so again, the small green one is half the length of the large green one. That is your triangle midsegment theorem. All right, so that's the first part. Next, they want us to find EF. Okay, well, EF is the long piece of your yellow relationship. So MO is parallel to FE, and we know that your midsegment MO is half the length of the whole thing. Or double your midsegment is equal to the whole thing. Okay, meaning if I double, EF is equal to double the length of my midsegment MO. If this segment is parallel to this segment, well then EF is double the length. So EF is going to be 2 times 13, which gives me that EF is 26. Okay, so again, your midsegment is half the length of its parallel side, or the parallel side is double the length of your midsegment. Okay, that's going to be your relationship here. All right, last one. It wants us to find ON. Okay, this one's a little harder. So if I know that DM is 11, and I can see that these two lengths are congruent, well, then I know that this length is also 11, making my whole length 22. Okay, so if my whole length of the purple segment is 22, well, I know ON is equal to half the length of my parallel side, 22. So ON is half 22, which is 11. Okay, so again, your midsegment is half the length of its parallel side, or that parallel side is double the length of your midsegment. And you're going to get a little more work with that right now, but if you're confused, please type it into the chat. I know this can get confusing and wordy. All right, next one, we want to find the values of the variables. Okay, so I know that this is my midsegment, and it is parallel to this side. All right, so I know that my midsegment is 50, and my length of my opposite side is 8y minus 3. So what we're going to do is we can say that 2 times my midsegment is equal to its parallel side. 2 times the little guy is equal to the big one. And then we just solve. So 2 times 50 is 100. That's equal to 8y minus 30. Add your 30 to both sides. You get 130 is equal to 8y. And I'm going to bring it up here. And then you take 130 and divide it by 8. You're going to get that y is equal to 16.25. And there's your value of y. Okay, so when you're given these with the variables, I'm going to always double the small piece and set it equal to the large piece. Okay, because it's much easier to double things than cut things in half in expressions. Okay, so again, when you are given figures or images like this, double the little piece and set it equal to the big piece. So we have our little piece, we have our big piece that are parallel. So I'm going to double the little piece, so 2 times 2x plus 10, and I'm going to set it equal to the large piece. And then we just solve. So you have to distribute the 2 to everything inside of the parentheses. 4x plus 20 equals 58. Subtract your 20 on both sides. You're going to get that 4x is equal to 38. And then you get that 4x is equal to 38. Divide both sides by 4. And then you're going to get that x is equal to 9.5. All right. So that is going to be another example of the midsegments. But again, when I'm given problems like this, double the little one and set it equal to the large one. All right, last thing you're going to learn about with midsegments is angle measures. All right, so let's first do part A. So it says find the measure of UW. So I want to find UW. Okay, well, the side that corresponds or is parallel to UW is ST. Okay, so these two sides are parallel to each other. And I know that UW is equal to half the length of the whole side, ST. And so when you plug that in, UW is equal to half 7.4. And when you take 1/2 of 7.4, you're going to get that UW is 3.7. All right, so that was easy. Now what it's asking for is the measure of angle SVU. This angle right here. Okay, well, notice that right here we have that this angle is 41 degrees. And what I want you guys to realize in these midsegments is because you have parallel lines, you're going to use those alternate interior, same side interior corresponding angles here. Okay, if I know that these two lines are parallel, which we already found, and this is my transversal, well, then these two angles are going to be alternate interior angles. And remember that your alternate interior angles are congruent. So that means the measure of angle SVU is going to be also 41 degrees. Okay, so you're going to see a lot of those corresponding and alternate interior and same side interior angle measures in mid-segments. Okay, so keep an eye out for those. So go ahead and pause your video and work on the next few on your own. Unpause the video when you're ready to check your answers. Okay, for this one, I want to find the length of JL. Well, JL is parallel to PN. And I know that JL is equal to 2 times the mid-segment, which is PN. So when you do that, you get that JL is double 36, which equals 72. All right, so the length of JL is 72. Now we want to find the length of PM. Well, PM is parallel to KL. And we know that PM is 1/2 the length of its parallel side, KL. Okay, so when we plug that in, PM is equal to 1/2 of 97. And when you take 97 and divide by 2, you're going to get 48.5. So there's your 2 different ways right here to find your mid-segments. You're either going to be given the mid-segment and you double it to find the long side, or you're going to be given your long side and you're going to take half of it to find your mid-segment. All right, last thing that it's asking for is the measure of MLK. So I want to find this angle right here. So again, I can see that these 2 angles are these 2 sides are parallel. I'm given this angle is 102. If this is my transversal, well, then these are corresponding angles. And we know corresponding angles are congruent. So that means my measure of angle MLK is also going to be 102 degrees. Now remember, in these figures, you're going to have side lengths and degrees everywhere. So you need to make sure you are keeping track of what degrees go with what and what side lengths go with what. Easy reminder, you will never have a side length that has a degree symbol. Okay, a side length will never be a degree. It will always be a length, so you won't have a degree symbol. All right, so go ahead and get started on the worksheet. If you have questions, please let me know. Otherwise, have a good day.